if we consider one expression, x square into x plus 1 to the power 4, say this is the expression. So it's easily you can do it by expand of this expansion, this one by using the binomial expansion, which gives a huge 5 terms are there, then we need to multiply. Without breaking down, we can do another way. That rule is called the product rule. So this is our topics. So for doing that, we need to consider just two. The first one, if we consider as a u, and second one, if we consider as a v, then see that two expression actually written here as a multiply form, uv. So let me consider as a formula d by dx of uv. So this will get out if we can differentiate u into dv by dx, then plus v into du by dx. That is our product rule formula. We are going to apply this formula only for the today's topics. So this is let you start. U given as a x square, so if we differentiate du by dx, it gives us 2x. We learned it before. And another part, which is v, x plus 1 to the power 4. If we differentiate dv by dx, from here we got 4 into, according to the chain rule, x plus 1 to the power 3. And if we differentiate inside the bracket, we would get from here 1. So there is no change take place, so it is only 4 into x plus 1 to the power 3. So now let we apply this formula here. If we write here d by dx, then our formula is u first, see here u, then dv by dx. So u into these two we needed to multiply here and there. U is x square we got from there, into dv by dx, which is 4 into x plus 1 to the power 3. Then the next term is v into du by dx, which we needed to just put the value from that to part, v, which is x plus 1 to the power 4 into 2x. So let me write it simplified form, that is 4x square into x plus 1 to the power 3, or you can write it say plus 2x into x plus 1 to the power 4. So we can leave our answer here. If we don't use this one in any other purpose, that is our answer. We also can write it in the simplified form, but for understanding the product rule, that is enough. If they don't ask you to do anything, so we can leave your answer here. Let's consider another form, another question from here. Say if we write here one expression, say x minus 2 to the power 5, and another expression is x plus 1 to the power 4. Similar method we needed to apply if I write that d by dx. So again we need to consider the first one, if we consider as a u, second one as a v, and that is our formula. This is our formula, this is our formula. So let me write, if I write there u equals to x minus 2 to the power 5, then our du by dx, we can write it 5 x minus 2 to the power 4, and if we differentiate inside, we got 1 from there, so we do not need to write even. And here v is given x plus 1 to the power 4, so you can write it say dv by dx, which is 4 into x plus 1 to the power, from the power we need to subtract 1, which is 3. So if we do or break down it in that method, so we needed to apply here the binomial for u and the binomial for v. It's a huge lengthy procedure, so we should not apply this one. We need to apply the formula u by v, but we will get the same answer even. So according to the previous question, the way we did u into dv by dx, so we needed to multiply this and that term, just write there this and that term, which is we can write it 4 into, so 4 into, if I write there x plus 1 to the power 3 first, then another part is x minus 2 to the power 5, then plus v into du by dx, v into du by dx, so that we needed to multiply middle two, so which you can write as a first, let me write 5 first, then x minus 2 to the power 4, and another part is x plus 1. So if we go for simplification, let me write the simplified part, we can write it x plus 1 to the power 4, yeah, x plus 1 to the power 4. We also can write it by the simplification form, but we do not need to write here. Let me write this one as answer. If they ask you only the differentiation, then you can leave your answer here, but sometimes you needed to do its simplification because otherwise you would not get the answer. Okay, let's see another example similar type. It's not that much easier product rule because we needed to differentiate two part together. Let's see one example. It is given here, root x plus 1, and another expression is given, say x plus 2 to the power 4, x plus 2 to the power 4. Similar method. First one we can consider as a u, second one we should consider as a v. So d by dx, so our formula is, we know u dv by dx, then another one plus v into du by dx. So just let you differentiate and put the value here. If I consider u, so u is here x plus 1 to the power half. So if we differentiate du by dx, we got from there half into x plus 1 to the power half minus 1, which is minus half. We can write it like this. Inside, if we differentiate, then we got the 1. So if we multiply 1, it would be the same. So v is written here x plus 2 to the power 4, which if we differentiate, we got from here dv by dx, which is 4 into x plus 2 to the power 3. So that is our expression. So now just put our values here. So our formula is u first, then dv by dx, u dv by dx, that too is u and dv by dx. Let me put it there. So which you can write it 4 into x plus 2 to the power 3, then the part is x plus 1 to the power half, then next part plus the formula is v into du by dx, v into du by, we got this one, v into du by dx. So actually which one we're going to write first, it doesn't matter because both are in the multiplication form, you know. Half into, we can write it first, say x plus 1 to the power minus half, then the next part is x plus 2 to the power 4, x plus 2 to the power 4. So we can write this is our answer. So that is the total things of the differentiation. Let me do another type of question. So we have done three parts of the differentiation, if written as a product. So application of the differentiation, say in the product rule, it is written here, find the gradient of the curve if that expression at the point x equals to 2. So similar procedure, we know the gradient is dy by dx is called the gradient. So let me differentiate first dy by dx. So here is the two functions. Definitely first one we would consider u, second one v, because two are as a multiplied form. So our formula is u dv by dx. You can write also like this, x plus 1 whole square d by dx of x minus 3 whole cube, u dv by dx plus v, which is x minus t whole square, sorry, whole cube, then d by dx of x plus 1 square. So just differentiate first part, we do not need to do anything, then into 3 bracket x minus 3 square. If we differentiate inside, then we got on, we could actually leave this without writing here because we do not need to write. If I multiply with the 1, the expression would not change. So the next part, which is x minus 3 whole cube, Then if we differentiate on the second part here, it gives us 2 into x plus 1. Accordingly, like 2 minus 1 is 1, and inside if we differentiate we got 1. Without writing 1 we also can write. So now we already have done our differentiation dy by dx. Without doing further calculation, let me put our value x equals to 2. They are asking to find out the gradient. This is the gradient expression. If we put the value x equals to 2, then definitely we will get the answer from here. So without further calculation, let me put the x equals to 2 here directly. So you can write here at x equals to 2, then you can write here the gradient, gradient, gradient equals to 2 plus 1 whole square into 3 into 2 minus 3 whole square into 1. We can use also calculator, minus 3 whole cube, then into 2 plus 1 into 1. So let me simplify. 3 square is 9 into this is minus 1 whole square means 1. 3 into 1 is 3. The first part we got like this. Second part plus, this is 2 minus 3 whole cube is minus 1. Then from there we got 3 to the 6. 3 to the 6. Yeah, let me write. So 27 minus 6 1 is the 6. So which gives us 21 is our answer. So at the point when x equals to 2, this is our gradient. I did myself this question manually, but I would suggest you to use calculator for doing that, because you needed to do it correctly, accurately. And another thing, if I did any mistake, please write in the comment below that in that part in this question you did mistake. You are welcome to write there, because I am doing this one without cut out anything. Directly I am doing mentally. Another question I prepared for you, which is the product rule. By using the product rule, you needed to do it. Find the x coordinate of the point on the curve where where the gradient is 0. So gradient is 0 means you needed to consider just dy by dx equals to 0. Then you can find out the x value from here. Why? Because dy by dx is called the gradient expression. So let you differentiate first. It's also the same differentiation. Let you write it dy by dx. Then our formula is u dv by dx, x plus 2 whole square divided dx of twice x minus 5 to the power 3. Similar method we applied here. You know that u v, if I write the formula, this is u dv by dx plus v dv by dx is our formula. So we applied here the first one, we can consider u, second one as a v. But if you change it, first one if you consider v, second one u, no problem, you would get the same result. So next v twice x minus 5 to the power 3, and the second part is sorry, we need to write here dy by dx, dy by dx of x plus 2 to the power square. So now differentiate it, which gives us x plus 2 square into 3 into twice s whole square, because as a power we differentiate, and inside the bracket if we differentiate, then we got the 2. So this is very important, because we needed to apply here chain rule. This is called the chain rule, but we did not write here anything. So that part is done. Now go for the second part. 2x minus 5 just as a in front of dy by dx written, then differentiation would take place on the second part, 2 into x plus 2, because 2 minus 1 is 1, and inside the bracket if we differentiate we got from 1. Let me simplify it now. So the expression you can write 3 to the 6 into, we needed to simplify right now, otherwise we cannot find out the value of x from here, it would be difficult. So then the second part is written 2 into, relative write in the order first, twice x minus 5 to the power 3. That is our total expression. Now we can do one thing, we can take common, because we needed to consider the gradient equals to 0. Before that, let us factorize first. We can take 2 common, so 2 is the common as a number from the two part is here, first part, and second part is here. From there we are taking common, the way we are doing the factorization. So if we take 2 common, and we also can take x plus 2 as a common from the first part, and second part is square, second part is x plus 2 written there, and another part we can take common, which is twice x minus 5 whole square. So let me write the remaining part with the curly bracket. So from the first, it is the 3 remains because I took 2, and x plus 2 square is written here, 1 I took, so 1x plus 2 is it remains here. Let me write it. Then the second part, 2x minus 5 whole square is taken. Then the second expression, from the second expression, 2 taken, x plus 2 taken, x minus 5 whole square taken. So I think plus 1 expression twice x minus 5 is remains here. Let me write it. Now just remove the curly bracket and simplify, we would get the answer from here. We are almost at the ending part. Just break down it. 3x plus 3 to the 6 plus 2x minus 5, one more line needed to write, 2 into which is x plus 2, then the part is 2x minus 5 whole square, then the last part is 3 to the 5x plus 1. That is the total expression of the dy by dx. Just we needed to consider that one as a 0, then we would get the answer, because the question is ask you x coordinate only. X coordinate means the x value, they did not ask you the y value as well. So therefore we can write the expression we got dy by dx, which is 2 into x plus 2, 2x minus 5 whole square, another part is 5x plus 1 equals to 0. Now see, 3 factors are there, so if their product is 0, definitely the individual we can consider as a 0, 2x, then twice x minus 5 whole square equals to 0, 2 factor, and third factor is 5x plus 1 equals to 0. So the x value we got from here minus 2, from the second part it would twice x minus 5 equals to 0, because square is given 0, x equals to, we got 5 by 2, or we also can write 2.5, and the last one from there we can write it 5x equals to minus 1, so x equals to minus 1 by 5. So this is our answer. I'm extremely sorry to make this video longer. So that is the total thing of the product rule. There are a lot of questions, similar questions in the Edexcel and Cambridge. So we will discuss about that questions later on, question paper type. So